talking about how we do XOR, right? XOR. And we're just going to do a little exercise here. Okay. So let's talk about, oops, still the XOR operation. So I'm sure you learned this when you took in one of your classes. You learned about the truth tables. And so that's really what I'm going to look at. So the rule with an XOR operation is you're going to have a sequence of bits, right? And then you apply another sequence of bits. You're going to perform the XOR operation. And so the question is, what do you get here, right? What is the result? So based on the type of operation you're applying and so on, you should get a specific value. So in the case of XOR, it's like it has a rule. So XOR basically is one or the other, but not both. So that's how you can remember it. One or the other, or not both. Another way that you can remember this is just by looking at the truth table. Truth table. All right, and that's just going to be, you know, let's say I have 0, 0, 0, 1, 1, 0, excuse me, and 1, 1. So I'm going to perform an XOR operation here. And my result should be, according to that, one or the other, but not both. Okay, so that means it's going to be 1, right, here. And here it's going to be 1, but here we have both, and here we have both, right? So 0 and 0. So that's the result of the XOR operation. That's what you always do. So that, you know, if it's both the same, it's 0. Otherwise, it's 1. Okay, and so that's, you know, our truth table for the XOR operations. So now, now you won't really have to do this by hand, to be honest. I mean, we're just going to use Python functions. Python has a way of doing XOR operation very easily. Okay, so let's do an example to kind of drive this a little bit more. I'm going to do an example here, and I'm just going to say, so I'm now going to put it in the context of cryptography. So I'm going to say, you know, I have a plain text message. I have a key, and then I'm going to have the cipher. So I want to do that operation. So the plain text is going to be 1011 1101. Right, so that just a random sequence of bits there, or rather that would probably have a pattern because it's your message, right? Now the key should be a random sequence of bits as much as possible. So let's imagine it's 0, 0, 1, 1, 0, 0, 1, 0. Right, so that's your key. And then now you're going to perform the XOR operation, right? So we're going to perform the XOR operation. So we know this is a 0, this is a 0, this is a 0, 1, 1, 1, 1. And this one, what's this one?
1.
1.
1.
Exactly. That came out so crooked. I don't know why. let me redo that. Sorry. So it should be 1, 0, 0, 0, 1. Okay, so that basically, yeah, that's correct. Okay, so that's it. So we performed an XOR operation on those two. Okay. Make sense, guys?
Yeah.
Well, great. Now let's take a minute now. Usually, this would have been let's see. Let's do another example. Let's do another one. Let's drive it to a second example. What's this? Okay, we're gonna do another example. Example number 2. Again, I believe this is should be different. Yeah, this is different. Okay, so I'm gonna take now. I'm gonna encrypt. So this is going to be encrypt. All right, so we can see here encrypt. Okay, so we have message, we have key, and we have cipher. Okay, so that's going to be the encryption process. So now I'm going to just do it a little bit more complete. I'm going to have 0, 1, 1, 0. Sometimes I do this. You might see me do that. It just means a 0 when I want to distinguish it from an O. 1, 1, 1, then 1, 0, 1, 1, 0, 0, 1, right? And I'm going to perform the XOR operation. Okay, so again, this should give me, 1, 1, 0, 1. What about this one?
1,
1, 1, and the last one?
0.
There you go. So that's the encrypt process, okay? Now, we need to do the decrypt process. So decrypt, it's going to be, we define decryption, right? We have the algorithm. So at this point, we can summarize that the decryption algorithm in its simplest form. Now, this is a decryption algorithm, but it's not the decryption algorithm of, let's say, DES or AES. That's what you need to understand, is that this is really, it is in a sense a decryption or an encryption algorithm, but they're the most basic of encryption algorithms. Okay, so usually we're going to see something called a one-time pad, which basically tells us that this algorithm, a one-time pad, OTP, is going to tell us that that algorithm, which is just defined as K XOR C, could in fact be 100% secure. It could, in theory. Unfortunately, in reality, we're going to see why we cannot actually use such a simple one. And so what people do is that they have created DES and AES, which are built on top of that operation, but they just have more complexity. Okay, they have a lot more complexity, really. It's almost like saying they just perform tons of XORs and they jumble the data that way and this way. And so that's why later on we're going to see how DES works. But really all they're doing is, at the end of the day, is an XOR operation. And we're going to see that just that XOR operation could be enough in theory, but in practicality, it is not practical to use. But we'll talk about that in a second. And so therefore, we need to add complexity to improve the algorithm. All right, so that's the encryption algorithm. The encryption algorithm is K message, right? And that's going to be K XOR message. And in its simplest form, that's what we are doing here. Okay, that's what we're doing here. So now to define the decrypt algorithm, I'm going to take the cipher, the key, and the message. Okay, so again, I'm going to do 1101, 110, right? Just taking that cipher there. See that they're the same. So it's 1101, 110. We have the key already. That was 1011001. So the key is 1011-001, and we perform the decryption yet again on the cipher and the key to get back the message. All right, and so we apply the XOR operation. So that's 0, right? And that's 0110-111. These two should match because it's the whole process of encrypting and decrypting. Do they match? Yes, they match. And so we are correct. Is this clear, guys?
Yeah.
Are there any questions?